Okay, we're going to solve binary tree vertical order traversal. Uh, the goal here essentially is to traverse a binary tree vertically and then output each, uh, you know, output all the nodes found at each column from left to right. So here in the output, you can see that we first have a 9, and then we have 3 and 15 in another vector, then we have 20 in another vector, then we have 7 in another vector. So how are we going to do this? The goal is to ensure that that all nodes are covered, and if there are any overlapping nodes, then the node on the left should be uh, should be before the node on the right in the traversal. So so the best way to do this is to use a combination of queues and hash maps. So essentially what we do is for every node that we encounter, we start from the root node and we keep pushing uh, the for every we will traverse the binary tree, uh, and for every node that we traverse we will store which column it is as a pair into the hash map, or into the queue, and we keep popping the queue. Or so let's first decide on what we do in the hash map. So we will store the we'll store data in the hash map with column that the node is present in as key, and the value being the list of the nodes that are present in that column. So let's say for this column, let's say the column number is 1. So for column number 1 we will store a vector of 4. We will only store the node values. For the second column we'll store only 9. For the third column we'll store the values 3, 0 and 1. For the fourth column we'll store 8, and for the fifth column we'll store 7. So how can we do this? How can we store these values with their column number on the hash map? Um, so we will try to we will just do a breadth first search essentially. Um, for every node we will just push it into the queue. We will uh, so for every node we will store the node value, and or we'll just store the node and uh, the column that it's present in. We will make sure that the root node is at column 0. The nodes to the right of the uh, nodes to the right of the root node will be in column 1, and this will be in column 2. uh, nodes to the left of the root node will be column -1. This is column -2, and so on. We can use that and store nodes into the queue, and for every node that you pop out of the queue we will also make sure to have a minimum column and a maximum column value, so that towards the end when we are finding out values from when we are extracting values from a hash map, we'll know where to start and where to end. So yeah, that's what we're going to do. uh, and then after iterating the hash map, we'll store it into a final vector of vector int called result. So we'll first declare that vector int result. This is the variable where we store the answer and finally return. So I'll just return result so I don't forget it later on. Now I also said we will have a hash map that will store the column, which will be an integer, and the list of nodes present in that column, which will be a vector int. We will only store the values. Okay, we will also declare a queue for our breadth first search, um, and the queue will store, it has to store the column value and the node. So it will be a pair of node and the column value. Okay, we will initially push the root node with column value 0. Okay, and I also said we have to maintain a minimum column and a maximum column variable so that when we are iterating over our hash map later on, we will know where to start and where to end. Uh, so while queue is not empty, we will pop the queue. Yes, set queue dot front, and yeah, we will get the node and we'll get the column. So three nodes dot node equals p dot first and int call equals p dot second. Now we will update our hash map by inserting the node's value into the column as key, and after that we will uh, we'll first we'll update minimum column, and we will update the maximum column because we have a column value ready there. Then if nodes of node of left exists, then we will push the node of left's value by decrementing the column number. So q dot push node of left should be there. Node of right exists. Okay, that's it. Now we have updated our hash map essentially. Once we exit this while loop, after iterating through all nodes of the binary tree, now we will iterate the hash map starting from minimum column to maximum column, and we will push them into our result variable. Okay, so for int call equals int call is less than equal to max call plus plus. Um, if call exists, just umap dot find call is not equal to umap dot end, we will push into result, which is umap of call to give the vector of node values present in that column, and we finally return result. That's it. Okay, forgot to pop here. Yeah. Hmm. Okay. So there is one base condition that we forgot. If root is null, we will immediately return result here. Okay. See if this works. Done it again. Oh no, accepted. Yeah, we were getting that error because we were trying to access r- null's value, which doesn't exist. Uh, so yeah, it was giving an error at this line. Yeah, and that's it. And that's how you solve binary tree vertical order traversal.